Hello, this is Ms. DB, and in this video I'm going to go over how to do some of the problems from the 9.1 worksheet. And note that there is a separate notes page to open and look at for this. There was so many notes and formulas and pictures that it would have taken up, 6 extra pages of your worksheet. So there's just a few formulas on your worksheet. The rest are on this notes page, and you need to look at it to find out how to do some of the problems. If you don't, you won't know how to do some of the problems. So all that's on here is the formulas to refer back to, not how you would solve the problems. So here's some of the problems. Some of them are very basic, like number 1, find the area of the parallelogram. So you can go up, even on this one, you can just look up here, find how to find the area of a parallelogram, use the formula, and solve it. Most of them are not that simple because this is geometry and not middle school math, so you're going to have to work harder to find the answers for most of these. All right, so I am going to do number 2. So it says that the area is equal to 136. They give us that the height of this rectangle is 8, and you are trying to find the base. So in this problem, you can use the formula, which is that area of a rectangle is equal to the base times the height. Now you may have learned it length times width. It'll work the same way. And then the area is 136, so that goes over on this side of the equal sign. The base is what we're looking for. The height is 8. So you would divide both sides by 8 to find the answer. Okay, in number 3, the area of a trapezoid. So you can look in your notes to find the formula for area of a trapezoid. And in the notes, it shows you how they got this formula. So that's quite interesting. And then here's the area of a trapezoid. It's related to the area of a triangle, but you have to add the two bases together, which are the two parallel sides, multiply by the height, divide all of that by 2. That's equal to the area. So the area, why is my pen not working? The area is equal to the two bases added together, that'll be the 11 and the 15, multiplied by the height, which in this one is 7, and all of that, after you find what that is, divided by 2. When you find the answer to these, your units will be squared for area. So the answer for number 2 will be whatever your answer is, millimeters squared. The answer to this will be whatever you get squared. Now in let's find one that's a little bit trickier. Number 5 is a couple steps to solve this one. In number 5, we have the perimeter of a rectangle in which the area is 154 and the height is 11. Let's write down what we know. The height's 11. The area is equal to 154 inches squared. So we need to figure out what the base is from that information. So we set up a problem similar to that already. You would write the formula, area equals base times height, and then put the area over here. And we don't know the base, so we have to divide both sides by 11. So we need to figure out what is 154 divided by 11. 14. So the base is 14. Well, once you know what the base is, then you can find the perimeter. Now, there isn't really a separate formula for perimeter of all these different figures. The formula for perimeter, if you want to write it, is you add up all the sides. Well, if the base is equal to 14, then you can add up 14 plus 11 plus 14 plus 11. So you don't really need a special formula for that. Perimeter is always the sum of all of the sides of the polygon. So that's how you'll find the solution for that problem. And rhombus is kind of a fun one. If we look at our notes page, you can see the section on rhombuses is right here. So a kite or a rhombus is found with a very similar formula, the same formula, but it's a little bit different for the pictures. It's found by taking 1/2 of the diagonal times the diagonal. And the diagonal goes from one vertex to the one opposite. That's how you find a diagonal. So on this one, they tell us that AC is 14, and they tell us that BD is 10. So you just need to use the formula as it's written to find this one. This one will be pretty straightforward. And it'll be one diagonal, which is 14, times the other diagonal, which is 10. And then let's look at number 9. 9.1 says to find diagonal 1 of a kite in which the area equals 16x. So if they give you a variable, then you're going to have a variable for part of the answer. So here we have a diagonal, and here's another diagonal. All right, so the area of this is equal to 16x, and let's call this one right here 8. Diagonal 2 is 8. We're looking for diagonal 1. So again, you always start by writing down the formula. It's equal to 1/2 d1 times d2. We know that the area is 16x. Don't skip the x part. Then we have 1/2 d1, which we're trying to find, times d2, which we know is 8. Need a little more room here. So we're going to keep solving this until we're able to find what d1 is equal to. So on the right side, we can simplify. We can put together the 1/2 and the times 8. I'm just going to reorder the way they're written. And 1/2 of 8 is 4. So we know that 16x equals 4 times d sub 1. Now we can divide by both sides by 4. 16 divided by 4 is 4, so we get that 4x is equal to our other diagonal. And if you write that the answer is 4, then you're wrong because you don't have that x part of it. Let's look at number 12. So in 12, we're looking for the area of this square. You're asked to find the area of this square. The area of a square is found with the formula base times height, or there's a special one for square if you want. Let's look on this worksheet at the very top, if they have that listed. Here we go, squared. The area is equal to side squared. You can always just use base times height or length times width as well. So if they tell us that the area of our square is a minus b, then we know that the area of that is just a minus b squared. You can leave your answer like that, or you can say, well, I'd have to take a minus b times a minus b. Either way, and then you could FOIL that out. But you can leave it as a minus b squared if you want. And the area of a kite here, number 15. In this problem, it's very similar to one that's on the worksheet. Right here. See how similar? So I'm not going to do this problem, but if you're watching this video, you'll know to look back on the notes in order to see how to do this one. And 16 is the area of a rhombus with the diagonals given. I'm going to look and see if that's anywhere on here. Oh, right above it. See that? Same exact problem. So now you know how to do those two problems. Let's do number 17. Number 17 says to find the area of the rhombus. So we know that the formula is area equals 1/2 times diagonal 1 times diagonal 2. So the area is equal to 1/2. Now we'll plug in the diagonal 1 is x plus 4. Diagonal 2 is 2y minus 4. I think that's what that says. It's a little hard to read. And the area is that, but we have to simplify it a little bit. So let's see. We will FOIL, and we will get x times y for the outer. The first times first. The outer is x times negative 4. The inner would be plus 4y. And the last times last would be 4 times negative 4 is negative 16. and then we'll multiply everything through by this 1/2 just to simplify a little more. So that would leave us with 1/2 xy minus, what's 1/2 of -4? 1/2 of 4 is 2, so that'd be minus 2x. Then we have 1/2 times 4y, that'd be plus 2y. And then we have 1/2 times -16, that would be minus 8. So we don't get a nice, neat answer here, but we have an algebraic expression that would be correct for the area of that rhombus. So some of these are a little bit tricky like that, and you'll have some variables in your answers, and some of them are more straightforward. I'm just going to set up the trapezoid area here. We're looking for base 1, which is over here. They give us the area, but it's an algebraic expression, and it's found by taking b1 plus b2 all divided by 2, the area of a trapezoid again, which you can find a similar problem over here in your notes, like this. So if we are, oh, I forgot to put the height on there, sorry, times the height. So in this problem, we're given the height, and the height is the perpendicular distance between the two bases. So you might think 2x doesn't look like a height, but this is the height right here, 2x. This is base 2, and we're looking for base 1, and that's the area. So when we plug everything in, we have 4x squared is equal to b1, which we don't know, plus b2, which is 3x, times the height, which is 2x, all divided by 2. So the first thing I'd want to do when I start to simplify this is multiply both sides by 2 to undo that dividing by 2. And that leaves me with 8x squared equals, the 2's cancel, so you don't use that at all. I'm trying to decide what would be the best step next. I think I'll leave the b1 plus 3x in parentheses multiplied by 2x. Now we're trying to solve for b sub 1, so we want to get it all by itself. It has 3x added to it, and then that whole thing is being multiplied by 2x. My next step, I'm going to divide both sides by 2x to make this be a simpler problem. It's not the only way to do this. You could multiply through by 2 sub x and then keep working, but this might get me a little bit simpler problem. So on this side, the 2x and the 2x cancel. Now on the left side, I have 8 divided by 2 and x squared over x. X squared is the same as x times x over x. One of those x's cancel, and I'm left with 4x. And on this side, then, I just have b sub 1 plus 3x. So you just have one step left to find b sub 1, the base that you're missing. All you have to do now is subtract 3x from both sides, and then you will know what the answer is. All right, well, good luck. As always, let me know if you have any questions, and have a wonderful day.